Alright guys, we're doing derivatives of trig functions. It says the goal for this lesson is to introduce the derivatives of the 6 trigonometric functions. It is vital to your success in this course that you commit all 6 of these to memory as quickly as possible. What we see, the derivative of sine is cosine. And I'm going to try to draw some connections to help you memorize them. The derivative of sine is cosine. The derivative of tan is secant squared. And the derivative of secant is secant tan. Now, you're probably wondering, why did she put those 3 together? I put them together because they're all positive. Derivative of sine is cosine. Derivative of tan is secant squared. You probably want to put these on a note card. Derivative of secant is secant tan. Now, if you look at your cofunctions, what do I mean by cofunctions? Well, the cofunctions, derivative of cosine is negative sine. The derivative of cotan is negative cosecant squared. The derivative of cosecant is negative cosecant cotan. Draw some connections. Look at sine and cosine, cosine, sine. Well, the derivative of cosine is negative sine. The derivative of tan is secant squared, where the derivative of cotan is negative cosecant squared. The derivative of secant is secant tan, where the derivative of cosecant is negative cosecant cotan. So all your cofunctions are negative, and all your non-cofunctions have positive derivatives. And what I always do is I write on my paper, the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, and then it comes back around to sine. The derivatives go down. The integrals, which we have not learned yet, when we start going backwards, we're going to go up. And I have a tendency to write this on my paper every time, because sometimes you have to find multiple derivatives, and this helps me figure out which one I'm looking for. And we're actually going to skip all the way to example 5, because examples 1 through 4 are just going through the proofs of those derivatives. If you want to see the proofs of them, go to chaoticgolf.com and click on this lesson in Mr. Lecky's. He goes through the proofs and he does a brilliant job, and I'm not going to try to compete with him. So if you want to know, that's fine. If you don't want to know, you don't need to know them. It says find the derivative of each function. Before you begin, state which rules you're going to have to use. The product rule seems to be the rule that people forget to use. Try not to be one of those people. So I'm going to go ahead and over here I'm going to write sine, cosine, negative cosine, sine. And I'm going to have to use the product rule because I have 2 different functions here. I have x squared and I have sine of x. So this is my 1 and this is my 2. So 1 d2, the derivative of sine is cosine, plus 2 d1. And that's it. Yay! Let's do another one. This one is a quotient rule. We have low, we have high. So, and sine, cosine, negative cosine, sine. The derivative, so it's low, d high, the derivative of cosine is negative sine, minus high, d low, over the square of what's below. If you want to clean it up, you can be negative x sine of x minus cosine of x over x squared. And that's as simple as you can get it. Just stop right there. Ooh, where's C? Where's C? Oh, look, it's a random AP question thrown in the midst of our lesson. Try that. Pause. Unpause. It says the graph of h, and just see if you're right. The graph of h of x is shown above. Which of the following could be the graph of h prime of x? Well, it's increasing, decreasing, increasing. So you need to have one that's above, below, above. And you know that this is a cubic. It's like a muscle man. So the derivative of the muscle man needs to be a parabola that's above, below, above. So E. C. Ooh, I'm checking my time. I'm almost out of time. Y'all are going to be coming in 6 minutes. I'm going to rewrite this as t to the 1/2 plus 4 secant of t, just to make it easier to take the derivative. G prime of t is 1/2 t to the negative 1/2 plus the derivative of secant is secant tan. The 4 just sits. Tan of t. And that's it. D. H prime of theta. The derivative of secant is secant tan, so 5 secant tan plus the derivative of tan is secant squared. How do I know these? I'm looking back at my paper. I'm supposed to have them memorized. E. I'm going to rewrite this as s to the negative 1, so I do not have to use my product rule. Cosecant of s. So it'd be negative 1 s to the negative 2 minus 10. The derivative of cosecant is cosecant cotan, but it's negative, so times negative cosecant cotan. So it would end up being plus cosecant of s. I hate using s, cotan of s. And the last one is a product rule. The derivative of cotan is negative cosecant cotangent. No, it's not. It's negative cosecant squared. So 1 d2 plus 2 d1. And you can leave it like that. And graph the derivative of natural log of x. Oh, we can't do that on our calculator. We can't do this yet. Or that. And that concludes this lesson. We'll come back to those a little later. And I don't know why I'm flipping through here. Stopping.